do it. It's go time.
Welcome to Go Time, your source for wide-ranging discussions from all around the Go community. Find us on the web at gotime.fm, on the Fediverse at GoTime, at changelog.social, and on X at GoTimeFM. Thanks to our partners at Fly.io, the home of changelog.com. Launch your app as close to your users as possible. Find out how at Fly.io. Okay, here we go.
What's up, friends? Do you remember when ChatGPT launched? I do. It felt like the LLM was this magical tool out of the box. However, the more you use it, the more you realize that's just not the case. The technology is brilliant, don't get me wrong, but it's prone to issues like hallucination on its own, but there's hope. There is still hope. Feed the LLM reliable current data, ground it in the right data and context, then and only then can it make the right connections and give the right answers. The team at Neo4j has been exploring how to get results by pairing LLMs with knowledge graphs and vector search. Check out their podcast episode about LLMs and knowledge graphs throughout 2023 at graphstuff.fm. They share tips on retrieval methods, prompt engineering, and so much more. Don't miss it. Find a link in our show notes. Yes, check it out, graphstuff.fm, episode 23.
Welcome to Go Time. I'm your host. My name is Kris. And today we're going to be talking about some of the news surrounding Go. Some fun collection of articles. The last time we did this, we got some really good feedback from you wonderful listeners, and you seem to enjoy that episode a lot. Not sure if there will be as much laughing in this episode, but we can try. We can see. Joining me today as co-host is Ian. How are you doing today, Ian?
I'm doing well. I do think we might miss some of Johnny's laughter, but we'll do the best we can.
Yeah, we'll still try to keep it fun and interesting and hilarious as best we can. So yeah, first up from our nice list of articles here is an article titled "Go Evolves in the Wrong Direction." And I guess the summary of this article is that the author feels that Go is getting more complex and dislikes this added complexity. And the most notable thing that he points out, or I guess a couple of notable things he points out, is the addition of generics in 118, and then the upcoming addition of iterators in 123. So, Ian, what are your thoughts on this?
Yeah, I don't know. I guess I do know. I think I kind of disagree. I do think it's getting more complicated. I don't think that's something we can say isn't happening. But generics, I think, was a needed feature, and I think it's worth the added complexity, especially since I think in a lot of everyday Go, you don't even notice it. And then the range over function iterators, I'm kind of skeptical about this, but I'm also really excited. I've played with it some, and it is like the function signatures are hard, and it kind of is confusing. But having a standard way to iterate is something that I've wanted in Go forever. So yeah, I don't know. What do you think?
I mean, in generics, it did add a lot of complexity to the language itself from like a specification perspective. But yeah, I haven't really seen them like abuse. I haven't seen them make things worse in any way. So I think it's like for the everyday Go user, I don't think it added much complexity. I think it just added complexity on like if you want to implement Go or if you want to maintain Go. And there's all sorts of very complex things about that. So I don't know if that complexity argument applies as much. And I think there have been some useful productivity gains for some things. Like I use the slices package like all the time now because it's just there. I'm like, oh, I can just do this instead of having to remember that wonky syntax that I'd always have to look up because I can never quite remember it unless I've been typing it a whole bunch lately. So it's just nice to break out the slices package and be like, oh, slices.this or slices.whatever. Especially slices.clone. That is one that I always was like, this is terrible. I don't want to have to do this 3 lines of nonsense to get a clone slice. So I think on that aspect, I don't really agree with him that like generics have made the language considerably more complex. As far as iterators, I'm not really sure how I feel about this because it's on the one hand, I really like this idea. I see his argument around not liking the potential complexity that can come from looking at a line that says like for range and have it previously been like, okay, well, that's like a static thing that's not going to like block for a long period of time trying to get the next iteration of something. And now that could be a thing that happens because you might be making a network request in there or something like that. But I think that's just like a thing we have to get used to over time, because it's more just like a regular for loop with a function in it, except sometimes that function might be like a little hidden. But I do think like the tooling we have now will make it blatantly clear that this is a function. This is an iterator powered by a function, and you got to dig into that somewhat to see if there's something we're going to dig into that to see, you know, what might be the issue at hand. But having designed things that have iterators in them before, I think this will be much better overall, because I think that is a very inconsistent pattern across not just the standard library, but across Go packages in general, of like, oh, do you have a next function that just returns okay if there's something you can get next, or does it return like we have a thing that just returns like an object in an error or an object in okay, and like there's just like so many different patterns, and it's hard to know like which one you should use in a given circumstance. And I think this at least helps out with some of them where you just want to use the kind of like object okay pattern, and then you probably have like a separate like error function, and then you have that kind of standard sort of like what the database SQL package does, where it's like, oh, you do the check the error afterward if you get kicked out of the loop. So I think it will be a useful addition. It adds a little bit of complexity, yes, but I don't feel like it adds such a tremendous amount of complexity that it's going to be like difficult for new people to learn this. I think it's going to be more difficult for people that have been writing Go for a long time to adjust to this.
Yeah, I think it might be a lot like generics, where you don't see it a lot in every day, but when you're implementing libraries, you're going to be using it, right? So I think it could end up being like that.
Yeah, I do think like the push-pull semantics are a little wonky. Like I don't know how I feel about them as far as like trying to implement it and trying to get all of that right. We have to see, I guess, how it all shakes out. I haven't looked at this in a while either, since it kind of first came onto the scene, so I'm not sure how much it's shifted from how it was before. But I mean, in general, I don't see how this like necessarily makes the language worse or makes it immeasurably more complex compared to how things were before, outside of that one instance of now you look at a for range statement and it could do something arbitrary in there. It could cause side effects. It could like pause for a long time. Outside of that, it's like, I don't know. There was this like kind of debugging argument that he was making that I was sort of following, but I'm not really sure how that's going to shake out in the actual implementation as far as like when you look at it, if it's going to look, I don't think it's going to look this weird when you look at it, the iterators, but.
Yeah, I think that's also something that can be worked out in the error messaging and the stack traces, right? I don't know. There's also an argument here that it implicitly transforms, returns, continue, breaks, defers, all of those. And I understand that that does add complexity in like when you're thinking, but as far as writing code, I think that makes it a lot more simple. I don't have to learn how to do these things outside of the actual keywords, right? Like trying to continue inside a not like a custom iterator now is kind of a nightmare.
Yeah.
Right. And there's been so many times I'm like, I would like to continue here, please. So I honestly do think it's going to be simpler overall, just being able to use your normal semantics and keywords.
Yeah, because that's like I was using the Goldmark package the other day, and it has like this AST walking thing, and you have to like return special things to be like, oh, continue or like exit or whatever. And I was like, this is kind of wonky. I don't know if I like this as much. And then also like error handling sucked a whole lot. And I think it's kind of easier to apply your own error handling if you can just do a regular for loop here or for range loop, because you can just have the captured error variable that should still work. At least I think it should work. I don't see why it wouldn't work.
I know there's also the argument that this is one more way to iterate, right? But I think that argument kind of falls flat because it's not like there were standard ways to iterate before, right? So we're not introducing a new standard. It's just we're agreeing on a pattern.
Yeah, making an attempt to consolidate or at least give people a predefined path to go on and not just like, what packages have you been using? And deciding how you want to design your iterator based on what packages you've seen. Now you have an actual like, well, this is how you can canonically do it in the language, and you can still go do it by another way if you wish, but this is how the way people are probably going to be most familiar with.
Yeah, so to sum it up, I'm not sure it's going in the wrong direction.
Yeah, it's kind of it's a very bold and broad statement. To be like, it's evolving in the wrong direction. I think I think the only direction that languages can evolve, especially if you want backwards compatibility guarantees, is to become more complex over time. Like, I think through that complexity too, you can gain simplicity, right? So I think there's a weird argument in here about like, yes, we have to keep all of these old iterator styles, but perhaps, not forever. Like, we have ways of deprecating things even in the standard library now. So it's like, it gives us a path toward all of the iterators eventually looking the same, or being able to like convert one iterator to like this style of iterator in the future with some like glue code or something. So it feels like it will have the eventual effect of making things more simple in the same way that generics had the effect of making things more simple. For example, from the slices package, right? Now you don't have to implement your own slices package or implement all these functions all of the time, or you don't have to, write those same lines of code that are kind of confusing if you don't understand that pattern already. I think most people, if you see the word slices.clone, you're like, I bet this clones a slice, right? It's very straightforward what that means. So I think like, yes, on the small scale, it might add complexity to the language, but I think on the large scale, it's making the language go in a good direction toward more of the simplicity that we want. Because, yeah, if you don't want to have any added complexity, then you just can't add anything to the language. And that is also a bad thing for the language.
Yeah, I like that small scale versus big scale. Like, it's making the ecosystem simpler, not the language simpler.
Right. And there is a kind of somewhat strange argument at the end here, too, where he talks about like, we should have more SIMD instructions and things like that because Go is losing in the performance space to Rust. And I mean, we can talk about this with the next article, but I don't really know if like Go is that great of a language for performance critical things. It's not terrible for performance critical things, but I don't think that's like the target that Go is usually going for most of the time. It's not like when I think of Go, I don't think of like, oh, I need like low level raw performance. I think like, oh, I want a language that allows me to maintain, large code bases that do, a whole bunch of different things. And I want to be able to actually maintain it with, a somewhat large team of people.
Yeah, I do think that's a good transition to the next article.
Yeah. So this one isn't so much of an article as it is a post on Reddit. And someone asked in our Golang, what software shouldn't you write in Go? And interestingly, I feel like the people that commented, like some of the top comments, I'm just like, you're all oddly wrong. Like most of it is about like, oh, garbage collection is a barrier. Like one of the comments literally says, garbage collection is a barrier for some hard real-time processes. And there was an interesting other Reddit thread I found. It was about same sort of thing of like, well, why do we keep saying that Go is bad at real time? And the argument and people basically said like, what do you mean by real time? Like, what type of real time constraints are you talking about? And this is very insightful. Just like, real time doesn't necessarily have to mean like as fast as possible. It could also just mean like at a fixed interval. But also like, we're not in the Go, certainly not in the pre-Go 1.5 era or in the even 1.5, 1.6 era where the garbage collection pauses were, 10 milliseconds out of every 50 milliseconds. Now it's sub-millisecond max garbage collection pauses. I think it's like 100 microseconds is where they've gotten it down to for the longest, like worst case garbage collection pause, which for most real-time systems seems to like, that does not feel like it makes a large difference for most people as far as GC is concerned. So I don't really buy that whole argument of it's bad at doing things that need to be real time. But what do you think?
I mean, I get what they're saying, right? Like, I'm not gonna write some embedded like firmware in Go that needs to recalculate something at 100 hertz, right? Like that, it just doesn't make sense anyways. But yeah, I think people are still kind of confused about the stop the world GC stuff.
Yeah. And I think people like that also goes to like my thing I always remember of like, you don't have a garbage collection problem, you have a garbage problem. Like if the garbage collector is getting in your way, it probably means that you have done something pretty awful with your memory management and you need to go fix up your memory management. Like garbage collection does not mean you don't do memory management. It means you don't have to write as much of the code to manage it as intricately, but you still have to do memory management.
Yeah. I also saw a lot of arguments on here you shouldn't write like GUIs with Go. And I think I would tend to agree with that. Like that's just not what I would reach for. I think there are some like decent libraries now, but yeah, I don't know.
Yeah, I think GUIs is, especially when like the native platform like languages and APIs are like just so strong. I think it's kind of weird. I guess it depends on like what you're trying to do. If you're like trying to do like an open source project and you don't want to write 3 at least different platforms worth of GUIs, maybe you can do it in Go, but there's also like other tooling that can do that for you. Things like React Native or like even just using web views to do most of what you want and then writing in JavaScript and HTML and CSS. So yeah, I would say, yeah, GUIs are a little of a weird thing. I probably would try and learn the languages of the platforms I want to use over just like trying to use Go and shoehorn it for all the different types of platforms I might be using. Another interesting one here too was like the deeply nested JSON argument of like trying to parse that out. And I think that comes down to like, we don't have a culture right now of people implementing their own JSON decoders. People usually just want to throw a struct at the decoder and be like, please place all of the things into this nicely. Thank you. So yeah, I think without having better like custom JSON decoder building tools, those deeply nested, or really just deeply nested any type of like that, you know, configuration style language, whether that's YAML or JSON or maybe even TOML, it gets pretty hairy and annoying when you're trying to, you know, do some things in Go if you haven't built up that custom encoder or decoder.
Yeah, I think I agree with that. On the same line of decoding, encoding stuff. It's not in the article, but I would not use Go to write anything that interacts with like canonical XML, SAML, anything like that.
Yeah,
I've gone down that path, and it is, you end up like calling into a C library to make your XML canonical. And
oh yeah, if you need to do canonicalization, that's tough. I think XML in general is fine. Like I worked in an XMPP server for a few years, and like it was not like Go was not the issue at hand that we had, or Go parsing XML. It was pretty simple.
yeah, I haven't had as much issue parsing XML with Go as writing XML.
Yeah,
Go just doesn't handle like namespaces well. It doesn't handle other XML features well.
Yeah, I feel like that's probably also part of just like we don't really have good libraries for doing that. So it's like good libraries for doing that, then it's kind of rough to do it. I guess that's the same argument for like the deeply nested JSON or really like any of these encoding, decoding things. It's like if we don't write tools that make it easier to do those things, then it's just going to wind up being not great.
Yeah, I don't know if you've had to use SOAP with Go before. I would say avoid it.
I mean, I try to avoid SOAP in general, as a whole. I don't.
Sometimes you don't have a choice.
Yeah, it's true, but yeah. Oh God, SOAP.
I think my favorite comment on this whole thread though is Excel macros should not be written in Go.
Yes, and then someone disagreed, and they're like, "I'd rather write it in Go than Visual Basic." I was like, or VBA. I'm like, okay, yeah. I mean,
true, but no.
Sure. I mean, really, no one should be writing Excel macros. Those things are dangerous, but yeah.
I don't know. The custom function in Google Sheets are real nice sometimes, but that's just JavaScript. I don't even know what Excel macros are written in. Is it VBA only?
I think so. I don't know. I think you can write in a whole bunch of different like Microsoft languages, but it's just, yeah, I guess it's mostly VBA, especially if you want it to be cross-platform. But if you only care about Windows, I imagine you can write it in like C# or something. Maybe. I have no idea. I don't know how Excel macros work. I don't write them. I like spreadsheets. I don't like spreadsheets.
Job title, Excel macro engineer.
That could be the world runs on spreadsheets, so I'm sure there's many a people who have many a custom macros to make everything work. But yeah, anything else in this list of responses? Oh, someone said they write everything in Go. Oh God.
I'm actually like trying to answer this. Like, is there a class of software you should not write in Go? I don't think there is.
Yeah, I mean, I don't think there is. I think like there's software that might be slightly better to write in another language, and this is kind of like a thing I've been thinking about a lot lately. It's probably like another podcast idea or another podcast episode idea. But we can also talk about it if we have time, where I've been reading a bunch of Leslie Lamport's work, mostly because I haven't read the Paxos paper in a long time, the Part-Time Parliament. And I was like, I think looking for something else that he had written. And I came across basically Leslie Lamport has this very long list of all his written works. It's, I think, currently 193 works long. So he's written a lot of stuff over his career. And in the kind of blurb he writes about Paxos and the Part-Time Parliament, he's like, oh, this is a simple algorithm. And he's like, I don't understand why people don't understand this algorithm. So I sat down and I read that paper. And then after reading that paper, I was like, oh, this is kind of simple. And so I went through and like got a whole bunch of his other papers. So I'm like, I'm going to read all of these. And there's one of his papers where he's talking about teaching concurrency and kind of like his suggestions for how we should teach concurrency to students, specifically computer science students and computer engineering students. And there's this really great line in that paper. And actually, let me like pull it up so I can read it correctly. And he's talking about like computation here. So he says, how should we describe computations? Most computer scientists would probably interpret this question to mean, what language should we use? Which I think is kind of the question we're asking here of like, I don't know, what things shouldn't you write in Go? What things shouldn't you use this language for? And then he says, imagine an art historian answering, how would you describe Impressionist painting by saying in French? Which is just a hilarious line. And just, it's one of those like deep and subtle cuts at us as an industry. Because it's true. It's like we talk about like, oh, you shouldn't use that language to build that thing. It's like saying you shouldn't write that novel in French because it's not a good language. You should write all novels in English because English is a good language for writing novels. And it's like we should not be thinking about things in that way. And kind of his point is like we should be talking about this stuff in form of concepts. And I think that's, true of this discussion as well, of like, I don't think that there are things that there certainly aren't things you can't write in Go if you can write them in any language. Right? Go is a turning complete language, which means it's equivalent to all of the other languages. There might be like missing APIs. You might have to like go do some FFI stuff into C to like make it work or do other weird assembly stuff. But there's not like a fundamental thing that you can do with Go and can't do with another language, or you can do with another language and can't do in Go. So I think it's like more about the concepts that matter and can you express those concepts well in Go. But also there's like the whole other argument as well of just like, I don't know, if you're doing a startup or something like that, or you're creating a project, is Go your strongest language? That's probably the language you should write that thing in, right? So if you're like, for example, when we were talking about earlier about GUIs, it's like, okay, if you need to build a whole bunch of GUIs and Go is your strongest language, perhaps it's just better to make a slightly uglier GUI and learn something like Fine, so you can just implement a GUI with that and then have the application you want and then move on, instead of having to like learn a whole new language just to build a GUI, right? It's like, oh, I've got to learn Swift and C# and I guess C++ for Linux. I don't know what Linux GUIs are made in, but go learn 3 other languages to go express this same concept seems kind of silly. It's like, yes, Go, oh, you want to like write this same story, but you need to write it in like 4 different languages now. Like that feels a little weird. If you could just write it in the one, it could still be accessible to everybody.
We're right back to the ask a question in software engineering, and the answer is it depends.
Yeah. I mean, I guess the answer to this is like, what software shouldn't you write in Go is mostly just like, I don't know, just write it in Go. Like, if you know Go and Go's your strong language, write it in Go. Like, and if that doesn't work for some reason or other reason, then I'll go write in something else. But I think it's I don't think there's any broad answers that work for this. kind of. And certainly, there's no broad answers that will fit into like a Reddit response that is reasonable to read, right? When people say like can't build real time systems in it, it's like no, like nuance is required there.
Like if I'm writing like Spark jobs, I'm not going to write them in Go though, because it's Python or Scala, right? Like that's the supported languages. Like I think there's an argument for tooling here, right? Like don't shoehorn Go into things where there is no tooling just because you want to.
I mean, it also depends on your goal though, right? Because it's like, if you have that argument, then there will never be tooling for that thing in that space, right? If no one does it, then there's never it's not gonna be in that space, right? That creates like those artificial barriers. And I think like even thinking in this way is indicative of, I think, of the problem that like Leslie Lamport was bringing up in that conversation, which is like, or in that paper, which is like, if we think in the framing of like certain languages are good for certain things, then we're not really thinking about the problem itself, right? We're thinking about this other colored version of the problem of like, okay, this problem in Go. And then it's like, oh, well, now if we go to another language, we have to solve that problem in a different way in that language, which is, I don't know, not the best of situations, but that's like a larger industry level thing we got to solve for.
Yeah, I agree with you there, but I think there's some leeway on both sides. Like at the end of the day, you got to make money, you got to get stuff done.
Yeah.
You got to get stuff done. I don't know.
Yeah, I guess it's like, once again, like the big view versus the little view from an individual person standpoint or a small company standpoint. Yeah, there's probably some things you shouldn't write and Go, and you got to make that trade-off. But it's also like a different type of question. Like there's a difference you pose a question to a company versus toward an individual, I would say.
Mm-hmm.
So, yeah, you're right. It's it depends. It depends.
It depends.
Yeah, that's, oh, Lord.
The answer to all the questions, it depends.
Yeah, there's a whole series over on Changelog. I think it's a Changelog and Friends series called It Depends. I did an episode. It was fun. There's many more episodes. You should.
I have not listened to that yet. I'll have to check it out.
So I'll go listen. They're good episodes. They're fun. All right. Do we have anything else to say on what software shouldn't you write and Go? It's
a choose your own adventure. I do think that leads interestingly into the make files written in Go, alternatives to make written in Go. Should you write an alternative to make and Go? I think probably yes.
Yeah. I mean, make is, for a number of reasons, pretty awful. It's like standard, which is nice, but like that whole only using like tabs thing and so many other weird syntactical things about make and make files is just exhausting. And like I for well-established projects, or I think ecosystems like C and that have this more baked into them, it makes sense. But for Go, it's always like make files always feel so awkward, weird in Go. So I think I've always like reached for some other alternative.
Have you used any of the alternatives mentioned in the article?
I think I've used Mage a few times. I don't think I've ever used Taskfile. Also, I hate YAML, so I don't think I want to use Taskfile.
Yeah, we use Mage pretty extensively where I work. And I think like one of the great parts about it is like I don't have to learn all the weird extrinsities. How do you say that?
Oh, extrinsities, yeah.
Of the AWS CLI for doing stuff. Like Go has a great AWS SDK, right? So we can do all of our like automated AWS stuff in a Mage file, and it just works. It's amazing. Yeah, I would definitely recommend.
That's nice. Yeah, and just being able to keep everything in Go sounds nice. I mean, yeah, having the full power of like a full actual turning complete language is nice, and not having to do kind of, as the author points out, all of this kind of bending over backwards to make stuff work with the shell and the weird version of the shell that make has.
Yeah. Being able to do real for loops is real nice.
Yeah.
Not that the shell can't do for loops, but I mess it up every single time I try.
Well, real for loops and logging and execution of parallel commands and a whole bunch of other stuff that's just like, this is like easier to do in Go than it is to do in other things. So yeah, I mean, I'm fully on board with things like Mage. Once again, when it comes to Taskfile, I don't really see. I guess if you don't want to learn make, like the syntax of make, and you're happy with YAML, then it's good. But I just really do not like YAML. There's just so many oddities. Like I was writing YAML inside of Markdown the other day, and it was like I was getting some weird error from it because I was writing it and it was like converting my tabs to spaces or spaces to tabs. I don't know which, but the YAML parser didn't like the fact that it was not using the correct spacing type, and it blew up with some weird error. And I was like, this is obnoxious. I don't like this. Like white space important syntax is not what I enjoy in life. So I would probably just sit down and use make, or really just use mage or something like that instead of task file. But I'm sure plenty of people like task file.
If we want to diss TOML or YAML some more, I think one of my most frustrating days ever was because YAML was not considering something a string I thought was a string. So you don't have to quote things, right? But every once in a while, that'll bite you. So
yeah. No, it's just a messy markup language for sure. I get why it was created, but there's a lot of things we create that sometimes are bad ideas. A lot of things in this industry we create are bad ideas, but but yeah, no, I think like Mage is cool. I think I've used it a few times in the past. If you haven't checked it out, you should definitely, listener, go check it out. Especially
would recommend.
Yeah, especially like the fact you can have like a directory of files, so you can kind of like properly manage the structure of it and have your own little like build system within your code base, which I think is helpful.
Yeah, we've actually used Mage inside of GitHub Actions too to help manage some of the like build and test scripts, and it works real well.
Yeah, it's like you're building your own little build system, which if you're only writing Go, it's a nice little thing to have. Yeah, I don't know. Is there much else we want to say on good old Mage or good old, what are these, alternatives to make files?
That's all I got. Do recommend, check it out. If it works for you, it works really well.
Yeah.
What's up, friends? I'm here with two new friends of mine from Speakeasy, Sagar Bachu, co-founder and CEO, and George Hadar, founding engineer. So for the uninitiated, Speakeasy takes care of the entire SDK workflow to save you and your team significant time, delivering enterprise-grade SDKs to your customers in minutes. You can generate best-in-class SDKs in TypeScript, Python, Go, Java, C#, and even PHP. So, Sagar, what's your excitement level for APIs and this API world we're living in?
I'm super excited about APIs. I think we went through Gen 0 of the API first revolution, and I think we're actually going to a second one now with the tailwinds of the AI ecosystem kind of causing that to be reinvigorated. So yeah, super psyched to be working in this space right now. I think everyone's at a point now where everyone knows about REST APIs and GraphQL APIs and gRPC APIs. And now I think we're actually getting into the second phase of that, which is how do people ship great developer experience in addition to the APIs? And how do we build like truly best-in-class APIs that turn into long-lived infrastructure, right? This is kind of the vision I think that Stripe helped manifest for everyone in the fintech space, which is an API that really sets the bar for developer experience, but also like it's something you can truly rely on, right? It's a true, if you make Stripe a dependency of your company, you can feel confident doing that. And I think that's the part of API development that really excites me.
I agree. That is exciting. So, George, teams who leverage Speakeasy are those who have leaned all the way in on documenting a solid open API spec and mostly want to be hands-off of their SDKs. Is that right?
Precisely. So you're coming to us because you want to be hands-off from that process. You want to put all of your effort into documenting your API, and then you're trusting and relying on great quality tooling to turn that into code and documentation, which is what we're doing for you. You're not meant to change or edit the code because it will be regenerated the next time you change your open API. So you ultimately put it in our hands. Once you've committed the changes to your open API, it's off to the races, and you get a new release of your SDK. You'll get a pull request to review. You will have the opportunity to look at the contents of the code, but quite often you can let it hum along creating SDKs for you or new releases of your SDK every time you change your API.
Very cool. Well, the thing that got me with Speakeasy that really helped me understand it was that, as George said, it is hands off. You can just focus on documenting your API via the Open API spec. And you still have pull requests, you still have visibility. And in fact, they will even hop into pull requests with you to triage any sort of anomalies or issues that come from the SDK generation and improve the back end of Speakeasy to make future releases better for you. I think this is so cool for teams who want to just be hands off of their SDKs and focus on their product, focus on the core documentation around the Open API spec, but still have all that awesome visibility. Okay, so the next step is to go to speakeasyapi.dev. You can start off with one free SDK. That's so cool because you can go there right now and try it out completely free. One free SDK. Let them know the changelog sent you. Let them know JS Party sent you. Once again, speakeasyapi.dev.
So the next article we have is titled "The Long Overdue Problem Coming for Some People in Go 123." This is kind of like an in the weeds article. This is talking about a specific compiler directive called Go link name that the Go team is starting to really lock down.
Yeah. Should we explain what it does?
Yeah. So I was about to explain what it does. So Go link name effectively allows you to reference an object or a symbol or something like that you would usually not be allowed to access. So, for example, you can use it to access a unexported, variable or function in another package. So if you have some package that has some type or some function foo that would only usually be able to be called from within that package, and you have another package, you can use this Go link name directive to be like, actually, I want to be able to call foo from inside my package, which obviously it's necessary for the Go team and for Go to have this for a number of reasons, but it also is, kind of not great because it means that now all of the things you meant to be private are not really private anymore. You can just kind of reach in and grab them and take them out and use them.
Yeah. A couple of notes on that. You do have to import unsafe to use this.
Right.
So the Go team is telling you like, hey, this is going to break.
Yeah. So the changes that they're making is that you can no longer just go in and grab something out of any package. In the next version of Go in 123, only things that are explicitly marked as you being allowed to do this will allow you to do it, which I just find to be kind of a funny thing, because then this is just like another way of exporting things. Because it's like,
yeah, it is a little bit weird.
Yeah, it's like I get why we're doing this kind of gymnastics to make this happen, but it's just kind of hilarious.
Yeah, you see it a lot in the standard library pulling in stuff from the runtime, right? Like, if they're going to lock this down, I wonder why there isn't just a runtime package that is used to pull those things in. Like, there's probably a good reason, but I don't know why.
Yeah, and I think this directive also was probably intended to be used for something else, and people found they could use it for this thing, and are like, oh, we'll just use it for this other thing. It's also interesting, like the particular situation of why the author kind of stumbled upon this was because of the Quick Go package that needed to get the default cipher suites for TLS 1.3. And in Go, there was explicit choice made that those cipher suites are not configurable. But also because of, does your hardware support AES? Does your client want to use AES and a whole bunch of other things? It's not like the default cipher suites might not even be like an actual like stable thing that you can reference, which is, it's like an interesting little quirk of this quirk is that, the reason why it's not an exposed variable is because it's an extremely complex thing that like can't really be determined until runtime and still might shift at runtime. So it winds up being like this kind of odd space, and that's why it's not an exported thing. But yeah, just a little bit of a weirdness. This whole situation is just weird overall. But yeah, it's like a little thing that's going to start breaking random things. I'm sure there's tons of just people that have used this as some sort of hack to get around something. And now stuff is just going to start breaking, and people are going to have to figure out how to fix that.
Yeah, and the proposal to do this, I think, is really interesting because in it, Russ Cox literally says, hey, this is going to break stuff, but it puts us on a good path forward, so it's worth breaking those things, which I think I agree with.
Yeah, I mean, once again, you probably shouldn't be able to just reach into other packages and tinker with their unexported things. Like that's not generally what we want to happen in the language. But yeah, I don't know if I have much else to say about this article. You got anything else?
Not really. I just think it's interesting that it exists and that it works outside the standard library.
Yeah, I mean, a lot of these directives are like interesting little tidbits of like, yeah, it's like I like once again, I see why these things are necessary. I think like Go link name is also used a lot when you want to refer to something in assembly. So you have like a function that's implemented in assembly, use this directive, and then it goes and grabs the assembly code. And when the linker is doing its thing, it connects them together, even though there's no Go version of that assembly. So I imagine that usage of it will be left alone. But yeah, no, it's interesting that this ever worked and that this continues to work.
I think an interesting thing also for this proposal to lock it down, the 1.23 iterators introduced coroutine functionality for iterators, right? So you don't have to call out to a separate Go routine and sync back up. And they say this will not be able, these new coroutine functionalities will not be able to be link named now or ever. So they've shut that down with this change too. So
Fascinating. Yeah, like little things that probably affect a very small percentage of the Go community as a whole, but might have profound impacts moving forward. Okay, and I think the last article we have in our list is called "Go Don't Name Packages Common Nouns," which I don't know if I agree with this one. This one's basically the author is saying like, find a different name, a longer name, a multiple noun name for things. And they give the example of the time rate package, which is in golang.org/x. And they basically argue like, hey, like rate is a really good variable name. So it shouldn't be a package name. And you should call the package like rate limiter instead. And I think I don't agree with it. I think like just because something might be a good variable name doesn't necessarily mean you shouldn't use it as a package name. Because at the end of the day, packages are effectively variables.
yeah, I mean, I agree with that, but the number of times I've accidentally called a variable URL with the URL package imported and been like, wait, why isn't this working?
Yeah, but like what else would you call the URL package? Like
I don't have an answer to that either. But what do you call the URL that you're building?
you.
Right? Like, yeah, I guess you're right. I don't know. The latter part of this section, he says in all of his internal packages, he generally prefixes them with like a letter, like with P in this case for crunchy platform, right? I don't hate this.
I mean, I hate the name of these packages in general. Like, I don't like naming a package server or DB or client just feels lazy. Like, it feels like your code base isn't structured well if you don't have like a delineation for the name. Like, what if I look at a package client? Then what is this? I guess if you're using the rest of the import path to say like what type of client this is, that works. But I guess it's just an outcrop too of me not liking having lots of small packages and would rather just have one big package and have it like, oh, you have like the, maybe it's the platform or the C platform packet that has a client in it instead of being like P clients. I guess there's times when this will crop up of like you have to have a package with this name for some reason or other, but I just think it's a bad pattern.
Yeah, like this shows up for me like in error packages, right? Like a lot of our services like have an in errors package where we define a bunch of our standard error behavior that's shared between different like subservices. And you don't want to call it errors because then you have to, if you're going to call it errors, I think you have to implement all of the general error functions from errors. Right. So yeah, we end up calling it like in errors. I don't know. Maybe that's just a foot gun I'm building right now that will come back to bite me. But I think there's some merit to it.
Yeah.
Like, I do think if you're going to have a package called the same thing as like a commonly used like standard package, you should at least implement all of the like methods and stuff inside that package.
Yeah. Yeah, it does feel like this is just another outcrop of like the naming is hard problem in computer science. Like it's really challenging to name things well. I guess in general saying like I think don't name things with a noun is like too blankety. It's like too much of a wide purview. I think it needs to be scoped down to something else. What else? I don't know, but I like using nouns for packaging.
I mean, if there was any hard and fast rules for naming, it wouldn't be hard, right? Like if we could create a rule set that made naming easy. I just don't think there is one.
Yeah.
But I hate long package names though.
Oh, yeah. Yeah.
So I would rather have it be short and maybe not as obvious than have a package called like this is my server.
Yeah, I don't think it's, but that's the thing of like, why do you have a server package? Like, why isn't it just server is a type in another package? It's like, it's not like the HTTP server package, it's HTTP dot server and HTTP dot client because it's the HTTP package. So I feel like that's why I don't really like, the suggestion of like, we should call it rate limiter instead of, the rate package. But then there's other rate things you could have in there besides a rate limiter. So it's, yeah, I guess it's just not like, if it's a very general type of noun that you would use, perhaps you need to come up with a more specific thing you want to call it, or make up a name, right? Take a name from another language of what that thing is and then use that. I've done that too many times in the past.
I will say what not to do is just give it a random name that means nothing. Like we have a lot of like things where it's like cat dog, named after an old TV show.
Yeah.
And you have no idea what it does. Don't do that.
Yeah. If you want to go with like the fun theme names, you got to really dig into the lore of whatever. It has to all be related. Like, yeah, that's what you like. Yeah. Like at a previous job, we were building something and for some reason we called it the Matrix. So I used Matrix characters for all of the different services, but it fit with what those characters were in the franchise. So it like made sense compared. It was a whole thing. But like you gotta go all in if you want to use some sort of reference like that and throughout your code.
Yeah, we had one called API card, like Apicard, like Picard, the Star Trek captain, and that one like worked because it started with API.
Oh yeah, Apicard. Yeah, no, that worked. I mean, I think that's how like they kind of stumbled into Go Please. Is they had Go LSP, and they're like, oh, we can just rearrange some of these letters. So sometimes stuff like that falls out.
Yeah, Go Please, like clear what it does. Well, I guess kind of. I guess I knew it as Go LSP before Go Please.
Yeah, but it's not like,
so it might be confusing.
Yeah,
it has all the right letters.
Yeah, but it's easy to like once you look at it, you're like, oh, that's what this is. Okay, but yeah, I'm not completely sold on the don't use common nouns for package names. It doesn't have enough nuance for me. It's not subtle enough for me. But once again, if it works for you, works in your code base. If you like the letter prefixing, I'd say go for it. As long as like everybody on your team is on board with that as well.
Yeah, it's like any other pattern. Like, don't just start using it. Like, if you're gonna use it and document it and tell everyone to use it.
Yeah. Do we have anything else to say about not using package names that are common nouns?
Not really. How do you feel about underscores in package names?
Ugh, no. I don't want to be typing an underscore when I'm typing package. That's just no.
What about underscores in file names that aren't test?
That's fine.
You think that's fine?
Yeah. So you want to be able to like read the file. Like I only have to type the file like once, and the file doesn't have like I'm not writing the file name in my code all the time.
Can you even put an underscore in a package name? I don't even know.
Yeah, you can't put a hyphen, but you can't put an underscore. At least I'm reasonably sure you can put an underscore. But yeah, I know I'm yeah, you can't put a hyphen, but you can't put an underscore. But yeah, I like if your package name is getting too long, I'm like there's something wrong. Like, yeah, got to rethink all of this. So Because yeah, once again, you gotta be typing that thing out all the time. And typing underscores sucks. I don't like typing underscores. That's why I don't want it in a package name. Once again, it also means that your package name is long, which means that your line length is going to get long. So you're using long function names there too. It's like yeah.
Yeah, I do think your idea that if your package name is getting too long, you're probably doing something wrong, and you should figure out what that is that you're doing wrong. But yeah, that's all I got.
I actually think you should probably leave.
Huzzah! Unpopular opinions. All right, Ian, what's your unpopular opinion?
Can you go first? I'm still thinking.
I'll make this complicated. Okay. Yes, I think I do want to turn this into an episode idea, but I have finally, I think, figured out why I don't want to say I don't like. I think it's better to phrase it as like I'm meh on Rust. Like I figured out why I'm meh on Rust, and the reason I'm like kind of meh on Rust, which is like not like a strong dislike, but like a slight dislike of Rust. Or like not even a dislike of Rust. It's mostly a criticism of the way that Rust is sold, is because of this other paper I was reading by Leslie Lamport. And let me just like, once again, pull up this quote because it's I want to get it right because it's just, once again, a deep and subtle cut, and I like it a lot. Okay, and in this paper, it's the paper is titled, if you want to read it, Computation in State Machines. And I'll just read this paragraph in the preface, and then I'll talk about why this is the reason why I'm meh on Rust. So he says, for quite a while, I've been disturbed by the emphasis on language in computer science. One result of that emphasis is programmers who are C++ experts but can't write programs that do what they're supposed to. The typical computer science response is that programmers need to use the right programming, specification, or development language instead of or in addition to C++. The typical industrial response is to provide the programmer with better debugging tools. This is the crux of it here. So the typical industrial response is to provide the programmer with better debugging tools on the theory that we can obtain good programs by putting a monkey at a keyboard and automatically finding the errors in its code. And for one, I find that last sentence to be hilarious. But I think that also like gets at why I've kind of disliked this whole aura of like type safety and memory safety and all of these other type of safeties will like fix the problems that we have with our code and with our software and with our programs. It's like it's a theory based in like I think a misunderstanding of where the problems with modern day software are and with where software development is. And I think that Rust and the kind of ethos around it, not saying that the language itself is not good and useful. I think it is good and useful. But I think that argument of like, we need Rust because C is not safe enough. So if we just had a memory safe version of C, then our problems would be fixed. And I know there's nuance. Like lots of people have a much more nuanced argument of that. Like it will solve some of those memory safety problems. And then there's other problems we have to solve as well. But the big selling point feels like it is, the way to fix the problem with so much of our software is to add this memory safety thing, to have this borrow checker that exists in Rust. And by having this, we will solve some large class of problems and issues that we have. And I think what that does is it masks that problem that Leslie Lamport points out of like, well, we're not getting the programs right. We're not writing we're not starting from the correct point. And if you don't start from the correct point, then you're just trying to like iterate your way toward a good solution at the end of the day, which is like the kind of, the whole monkey typing code thing is I think a reference to the, if you give an infinite number of monkeys typewriters, they'll eventually write Shakespeare. And I think that that's a lot of how we do treat software. So it's like, well, if you just keep banging at it, eventually you'll shove out the right thing. And we can bang on things faster if we have these tools that tell us when we're clearly wrong. And I think what we should be trying to do is teach software engineers specifically, and I think computer engineers as a whole, to actually think. Like, I think that's the problem we have. No one wants to sit down and think deeply about the problems we're trying to solve. And we lack some of the training in the languages that we would likely use to do this thinking and then this documenting of things, mostly like math. Like you can represent a lot of what we want to represent with simple math. And we kind of run to a language instead, which also harkens back to that thing of like, how would you describe impressionist painting? Like, oh, in French, right? Like we run to programming languages to solve the problems when the problems actually have to deal with the fact that we're just not writing correct software. We're not writing correct programs. And we don't even have the frame of reference to know what correct would mean in that case either. Like we never sat down and said, this is what we're actually trying to do. And so I think like when we try and run away from languages like C, which is what it feels like we're trying to do some of the time. Like people are like, no one should ever write C. No one should ever do this. It's like saying like, you know, English is a messed up language and there's a lot of weird oddities with it. So we should be moving everybody to Esperanto and nobody should write or speak in English anymore because English is so bad. And it's like, that's a silly argument, right? It's not just impractical. It's rather silly because like the problems with English don't usually have to do with like the structural language itself. It has to do with like the concepts. Like, are we talking about, you know, concepts incorrectly in English? And I think that's the thing with programming and with software. It's like, do we have the concepts right? Are we talking about the concepts right? And it's like, this is one of the reasons why I like Go, is because if you do sit down and you do really think about what you're building and how you're building it, and then you document that and you go through this rigorous process of developing it, Go is a really nice language to just express that simply and easily. It's a language that just doesn't really get in your way, and that when you need some help, there's some tooling there for you, but you don't have to use the tooling necessarily. And it also makes it easier to do it on a communal level. It has all of those things, right? Go popularized, Go funked, which is not like a, you know, correcting somebody's code, but it's making it easier for all of us to read everybody else's code so we can work collaboratively together. And so that we can see, you know, the obvious mistakes here and there between like, this is what you were supposed to do and this is what it's actually doing. So once again, it's not that I don't think Rust should exist. I think it's cool that Rust exists. I think all of these features that it has are very nifty, but I think that selling point of it really just soured the language for me because it's so much of that. It will replace C, or we have to rewrite everything in Rust because of blah, 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 blah. I think it's like much more advantageous for us as an industry to focus on how do we actually get people to write software correctly? And then also, how do we bring down the cost of software, which I think are two of the same thing. Because right now, I think we do have, you know, too many software engineers for this amount of software that we're producing, because for the most part, a lot of us are just monkeys banging on keyboards being like, oh yeah, I'm trying to write this thing. And oh, the compiler got mad at me. Oh, I guess I can't do it that way. Oh, I can't. And then you just kind of inflate the number of people you have doing software. And even though you're not really doing the thinking part of it, I think this is also what leads to people believing that you can replace software engineers with AI, with kind of like a more advanced version of the current AI we have, which makes sense if you believe that the whole we're just monkeys banging on keyboards thing is a reality. And like, yes, as long as we can correct the output of the AI, it will be a much faster monkey banging on the keyboard than a human could ever be. But if you recognize that, like, no, we actually need to have more thought in there than just blindly typing, blindly smashing the keys, then it's clear that AI is not going to be able to do those things because AI can't think. But yeah, that's my very long-winded reasoning for why I'm kind of meh on Rust. Still think it's a cool language, but like the way that it's been propositioned, I think, is what just sours me on it.
I think I agree with a lot of you said, but I definitely have a bit of a different perspective on it. Like, maybe Rust is saying that, you know, this borrow checker, this memory safety is going to save us all, and it's what has to happen. But in my perspective, like, we're all human. We're all gonna mess up, and we're all gonna design things poorly or write poor code at some points. And what these memory safety features and what Rust is trying to do is just minimize the impact of that mistake, right? Like if I'm just writing C and I let an index overflow and read arbitrary memory, like that has big consequences. But if I just can't do that, you know, I don't know.
I mean, I guess like there's kind of two sides to that too, where it's like, how much Like, how many of those types of problems are the problems we're having? I think it's relatively little that like the kind of memory like corruption problems we have are like the big things. I think a lot of the time, even when there are memory corruption problems, when there's like, buffer overruns and that, a lot of that gets patched. And the problem is that people don't update the version of the software they're using. So they're using some unpatched version that has the exploit in it, which is part of the larger thing. But I also think we like to think about things as if we have infinite resources and we can do things infinitely fast. But there's a reality that we can't really be spending huge amounts of industry effort on developing these things, but also be spending huge amounts of industry effort on really rethinking and redoing how we teach software engineers and then retraining the entire industry, right? Like, we're not doing that, right? We're not shifting toward that type of thing where we actually push software engineers to be deep thinkers, because that is a very hard, very resource intensive problem. Like, it takes a lot of energy to teach someone how to think critically. It's not a simple thing to do. And we just aren't doing it because I think we can get along well enough since we have these tools that make it so we can kind of produce software at least somewhat decently, because we have all these tools and all these protections, where it's like, no, like, you have to use C, and we actually have to find a way to teach everybody to use C well. I don't think that's an impossible thing to do, right? I don't think that's an impossibility that most software engineers should be able to learn and understand C. I don't think it's an impossible thing that most people couldn't learn and understand C. I think that we, as an industry, have just given up on that being a possibility because we have these other languages that are easier, and because we think that we can solve the problem through things like, we just add this one more type of safety. If we add type safety, we add memory safety, we add, what have you, that we will get to the point where everybody will be able to write software. So I think these things might actually be a little bit at odds with each other, but I definitely think like we won't fix this as an industry if we keep deluding ourselves into thinking that like the solution to C is Rust, or the solution to the problems we have with C is Rust. Because we won't fix the problems at the end of the day. I mean, it harkens back to like a thing that I've also been thinking about a lot lately with like a few years ago. We as an industry went through this whole thing of saying like, we need to get rid of these harmful, quote unquote, harmful words out of our code bases. So master and slave and blacklist and whitelist and all of these things. And there's a huge hubbub and people filed a bunch of PRs and we eliminated a bunch of these words, and like, Git, we changed it. It's no longer master as default. It's main, right? We went through all of this effort to change all of these things in this idea that like, using these words are harmful to, people of color, especially Black people, and they shouldn't have to see them every day and all of this. And I pushed back a lot on that at the time. I was like, this is not where we need to be spending our time. And people said, well, we got to do something. We should be doing some things. And like, we can do this and we can do those other things. And then you look at the same industry as the same people, and we're just like, full on embracing AI right now. And if you go look at the underpinnings of how all of this data is cleaned, how these things get trained, there's a lot of like subjugation of like, especially people of color going on, a lot of destroying of people's mental health and oppression. And like, where is that energy from our industry to push back on those things, right? We said, well, we'll get rid of these things. This is the first step toward fixing a larger problem. But then the follow through isn't there. And I think that's the same thing that sort of happens in obviously a different context for these other things. We're like, we got to make software better. So the way we make software better is by fixing the languages. But the languages aren't the problem. It's the concepts and understanding that's the problem. And that's where the Rust isn't helping. But it's not just Rust. It's like any of these languages that are like, we will, by making this language better, we will make it so you can write better software. And like, that's addressing the wrong problem.
So I guess at the end of the day, you're saying it's not the languages that's the problem. It's us that's the problem.
Yeah.
The engineers.
Once again, yeah. I think Rust is a cool...
I think I would agree with that.
Yeah. I mean, it's like, I think Rust is a cool language. I think people should use Rust. I think we should have memory safety. And I think the borrow checker is a really cool thing. And I think we should have type safety. And I think we should have all these tools that help us write software better. But we shouldn't forget that the primary problem with software today is not that we don't have memory safety. Like, we've been able to write many systems with really good without having memory safety. We've been able to write many systems without having type safety, right? And at the end of the day, your computer also, like, assembly doesn't have any of these things. That's what's running everything, right? The instructions at the end of the day don't have these protections on them. So it's like not having these things doesn't preclude us from writing good software. So we should focus on what are the things that will help us write good software, which I think that this could be a part of it once we actually teach people how to think about code and how to think about their programs. Because I think if you actually do sit down and you spend a lot of time thinking, you wind up with massively simpler solutions to problems. And if you kind of aggregate those things together, you wind up with massively simpler, larger code bases at the end of the day. Because if you don't, the problem just snowballs. Like once you're already in a mess, it's so much harder to get out of that mess.
Yeah.
So, we'll see how unpopular that is. I mean, it'll probably be pretty popular with Go people because it just said, Go is the ideal language for writing good software. Well, not ideal. It's one of the good ones. I would say like Lisp is probably one of the more ideal languages for the translation, at least from the view of computation. If you want to do it rigorously into actual code, you can run.
I think I do have an unpopular opinion.
Okay, go for it.
And this is something I want to do an episode on. I guess the premise is learning Go isn't easy. I know we say that a lot, like, oh, Go is easy. You can get it down in an afternoon. And I would go on to expand that learning any new language isn't easy. And it's not, when we say learning a language, I think a lot of people think learning the syntax of a language, right? Like how to do a for loop, how to assign a variable. And I think that's not even the tip of the iceberg. It's just the pointy part on top and nothing else, right? Learning a language is learning its paradigms, learning like how its normal libraries work. It's learning how to write idiomatic code in that language. And that's not like, you're never going to get that overnight. Like that's all going to come with experience. So pretending that any language is easy to learn, I think does the whole community a disservice, right? Acting like you can jump into a language and immediately write good code is I don't think realistic. At least it's not realistic for me. You just don't know enough to know if you're writing good code when you first jump in. So learning any programming language is not easy. Learning the syntax is easy. The rest is hard.
Yeah, I think I agree with that. Because I think like the way I was just kind of translating that in my mind was like, if you think about it in terms of like language as a whole, it's like, yeah, you can learn like the syntax and the grammar of like a particular natural language. But also deeply embedded into language is the culture of the community that developed that language. And it takes a lot of effort to learn that culture and to understand that culture, especially if that's a culture that is somewhat at odds or juxtaposed with your own, where it's like, okay, like, I think this is like the thing between like, I have some friends who are like Eastern Europeans, and the way that they express things and the way that Americans tend to express things is like vastly different, especially when it comes to levels of excitement. And I think that same sort of thing exists within programming languages, where it's like, yeah, no, the way that you express something in, I mean, Go and Rust are good examples. The way you do something in Go and the way you do something in Rust are going to be very different because the cultures of those communities are very different. So you might be able to learn syntax, but actually understanding all of that cultural stuff is real tough.
I think that's the perfect analogy for it.
Yeah. Yeah, no. So I think, yeah, it's, I think our unpopular opinions are like somewhat tangentially related, because it's like the tough part of all of this is like figuring out like, how do you express what you want to express in the language in the way it should be expressed in the language. And I think that's how you wind up with these languages that get, or these concepts that get siloed into a particular language, is because we like, oh, well, that language is easy enough to learn. Like I think Python and data science is a good example of this. Like, oh, Python is easy enough to learn, so you can do data science and data engineering in it. And that whole world just kind of gets everything built for it. But it's like, do the people doing those things understand conceptually what it is that they're doing, and they're simply mapping those concepts into that language? Or can they only express those ideas in that language itself, and they can't pull it out to another language? I think that's an actual more concise way of saying my own unpopular opinion. Is like, no, we need to focus more on having the conceptual understanding and mapping it into the language, as opposed to having the language be our only vehicle for expressing that conceptual thing.
Yeah, it's almost like we're learning things in the wrong direction, like
right.
Inside out.
Yeah,
instead of outside in.
We're hyper focused on language, which again is Leslie Lamport's point. Like I haven't finished reading the Computation and State Machines paper, but in that paper he basically talks about, he has this interesting thing in the beginning of it where he talks about like, oh, imagine if we didn't use equations in, say, physics. So you have two different parts of physics that had their own special notation, that it might not be obvious that like E equals MC squared is like the same thing in these two different parts of physics, right? Or, you know, for anything, right? If you use dissimilar syntax, then it's not going to be easy to recognize similarities and patterns between two different places, or that you had the exact same thing in two different places. And so his kind of point there was like, oh, well, you have equations, and just because like you have two equations that say the same thing doesn't mean they do the same thing inside of the, you know, branch of physics that you're operating within. In the same way, like you can, you know, if you put this into natural language, you can say the same English phrase to two different communities of people, and it could mean two vastly different things, even though the words are still equivalent. But you have the ability to kind of like understand and translate those things because you have the similar base of words that you're using and all of that.
Yeah, I have that issue talking to non-software people. Like a regular software term will slip into everyday language, and they're like, "What are you talking about?"
Yeah. That's the, you know, the beginner to master. Like, you know, you've mastered something when you can explain it to someone that doesn't have any context for what it is. Because like you understand what the concept of the thing is, so you can better bring that over to what people want to understand. So yeah, I think these would be two good episodes. Got to get some people that will probably disagree with me, and get Johnny on. Get some who else would disagree with me? Oh, maybe I can get Sam to come back. You can disagree with what I'm saying. And another, you know, gotta if I'm gonna have this as an episode of like, meh on Rust for all these reasons, gotta have people that are gonna disagree with me. This is assuming that they're gonna disagree with me. They might agree with me, and then it wouldn't be as fun. Or it might be.
Do you know Sam's stance on Rust?
I don't. I think he's. Nah, I won't speak for him. I think he's fine with it, but I don't know. That'll be a good thing to learn, right? Yeah. Yeah,
I'm interested to know. I'm still undecided on Rust, so.
Again, I'm probably gonna learn Rust. Like me being meh on Rust has little to do with like the language or its usefulness or utility. Like, I understand in the current context it is. It's a more macro thing, right? It's learn concepts, people. Learn how to think. That's the big thing. We all need to learn how to think. And I hope people don't think it's an insult. I'm not insulting us as an industry by saying that we don't think about things. Like, thinking is very difficult to do, and it's a very difficult thing to learn how to do, to think critically and intensively about things. Like, so it's not an insult to anybody to say like we're not thinking. It's just a thing that we should fix if we want to build better software. It's like, yeah, you gotta think. It's hard. It's hard work. We get paid a lot of money. We can do the hard work. But yeah, that feels like a good place to wrap it up. Any last words, Ian?
I think we've said it all.
I think so. Thanks for joining me, and thank you, listeners, for listening to this kind of all over the place episode. I hope you enjoyed it as much as the last one we did.
That is Go Time for this week. Thanks for listening along. Subscribe now if you haven't already. Head to gotime.fm for all the ways, or simply search for Go Time wherever you get your podcasts. You'll find us. Hey, do you receive our changelog newsletter each Monday? If not, let's fix that bug. One reader calls it so good, he considers it a competitive advantage. Sign up for $0 at changelog.com/news. Thanks once again to our partners at Fly.io, to our mysterious beat freak, Breakmaster Cylinder, and to our friends at Sentry. We love Sentry. You might too. Use code changelog when you're signing up for a team plan and save $100. Why not, right? That is all for now, but we'll talk to you again next time on Go Time.